Welcome to CHSG Science lesson. In this video, we will be revising P10, which is force and motion. The bigger picture of this topic is here. By the end of this video, you should be able to learn about the relationship between force and acceleration. You should also be able to calculate momentum, and also you should be able to determine the law of conservation of momentum and how the momentum remains constant before and after collision. In this situation, which stone is harder to move and why? Obviously, the heavier stone would be difficult to move. The heavier something is, the harder it is to move it. So it means when something is heavy, then you have to apply more force to accelerate it. So by looking into this example, we can say that force, mass, and acceleration are related to each other, and this is Newton's second law of motion. So force and mass are directly proportional to each other. So force and acceleration are directly proportional to each other. If you apply more force on an object, it will produce more acceleration. And also, mass and acceleration are inversely proportional to each other. If you have a heavy object, more mass, then it will accelerate less. So this is the equation. F is equals to ma. Force is equals to mass times acceleration. And as we know that the unit of the force is Newton, acceleration is measured in meter per second square, and the standard international unit of mass is kilogram. We will look into the worked examples. Find the force acting on an object with a mass of 10 kilogram and the acceleration of 5 meter per second square. So we have a mass and we have acceleration. We will use the Newton's second law equation to calculate the force. F is equals to ma. So for that we have mass and acceleration. So this is given data. Mass equals 10 kilogram, acceleration is 5 meter per second square, and we have to calculate force. We will use the equation to calculate force, and then our answer is 50 Newton. Similarly, for the second example, what is the acceleration of a mass 5 kilogram if the resultant force is 100 Newton? In this example, we are given mass and force. We have to calculate acceleration. So we have to rearrange the equation. So it is important to follow all of these steps. First of all, you write down the data, what you have it, and then you write down the equation, and then you rearrange it, and then you put your values in and your correct answer. So force divided by mass, 100 divided by 5, you will get 20 meter per second square. So based on this information I have given you, you can pause this video for 5 minutes and come up with the answers of these questions. Welcome back. So you can mark these answers. You can pause the video again and you can mark your answers. Okay, now what is the difference between mass and weight? Sometimes we consider mass and weight is the same thing, but in physics they are not. Mass and weight both are different things. Mass is calculated in kilograms, weight is a force, it is calculated in Newton. Let's have a look on the exact definition. The mass is the amount of stuff in an object or the quantity of matter in it. It is measured in kilograms. For any given object, this will have the same value anywhere in the universe. So mass remains constant. If you go on the moon or if you go on the space or if you go on the planet Earth, the mass would be same. Your weight of an object is the force acting on it due to gravity. So gravity is not same in the universe. So weight will be changed according to the gravity. So the unit for weight is Newton, as weight is a force, so it has the same unit as force. If you go into the space where there is a zero gravity, then there will be a zero weight, 0 Newton weight. If you go on the moon or other planets where the gravity value is different, then weight value will be different. So weight versus mass. Here are some examples. Earth's gravitational field strength is 10 Newton per kilogram. In other words, a 1 kilogram mass is pulled downwards by the force of 10 Newton. This is the equation, the relationship of mass and weight. So weight equals mass times gravitational field strength. This is the triangle to calculate or rearrange the equation. Here are some questions in front of you. You can pause this video for a next 5 minutes and use this equation to calculate the weight and mass. Well done. If you got the correct answers, you can mark your answers now. Okay, so what forces are acting on a parachutist? So when a person is skydiving, so his weight is acting downward and air resistance is acting upward. So when he jumps, the downward force is bigger than the upward force. So the velocity will be higher. So this is a case, consider a skydiver. At the start, the downward force is more than the upward force because there is no upward force when he starts falling down. As he coming down, the air resistance, the upward force is starting increasing. And there is certain point when the downward force is equal to the upward force, when his weight is equal to the air resistance. So that point is called when the skydiver attains the constant velocity, and that velocity is known as the terminal velocity. So you can discuss with your partners and come up with the blanks in. And now second case is when he opens his parachute, so suddenly the air resistance increases more than its weight. So while keeping down, there is another point come up when the upward force is equal to the downward force, and that skydiver will attain a second terminal velocity when both forces are equal to each other, and it will attain constant velocity, and we call that a second terminal velocity. So you can discuss with your partners for number 4 and 5 steps. So this motion can be described in terms of velocity time graph as we have discussed in the previous video. So you can see this was the initial part when the downward force was more than the upward force and speed was increasing. The parachutist or skydiver was continuously accelerating. And here was a point when upward force and downward force was equal to each other and we got the terminal velocity. And suddenly he opens the parachute. When he opens the parachute, then the air resistance was massively bigger than the downward force. So the parachutist slows down. And we call that the deceleration or slowing down his speed. So here comes up another point when the upward force and the downward force becomes equal to each other, and the skydiver attain another lower terminal velocity, and this motion is described in terms of velocity time graph. And after that, driver hits the ground. So that's the whole journey of a skydiver. If he is going on the moon, so there will be a continuous acceleration because there is no air on the moon. There is no air resistance, only downward forces acting on that. Based on this information, you can pause this video and do this exam question. Welcome back. You can mark your answers now. Well done if you got the correct answers. Here is another question. This is 6-mark exam question. Similar to what I have explained you in my graph. The graph shows how the vertical velocity of a parachutist changes from the moment of the parachutist jumps from the aircraft until landing on the ground. So using the idea of forces, explain why the parachutist reaches a terminal velocity and why opening the parachute reduces the terminal velocity. So this is 6-mark exam question. So you have to explain each and everything about his movement. So when he was accelerating, what happened to its speed and forces? When it attains the terminal velocity, what was the reason behind it? And you have to explain the other terminal velocity as well. So you can pause this video for 10 minutes to do these questions and then come up with your answer. Welcome back. Here is the answer key for that question for 6-marker. So you should include at least 3 points for first terminal velocity and 3 points from the second lower terminal velocity. You can pause this video here and you can mark your answer. The next important point is momentum. So momentum is a vector quantity, and this means it has both a size and direction. So momentum is a measure of how strongly something is moving, that how much force you have to apply to stop something is moving. That is the momentum. The mathematical equation for momentum is momentum equals mass times velocity. So bigger the mass, more momentum it has. Bigger the velocity, more momentum it has. This is the triangle by which you can rearrange your equation. So if two objects of the same mass are moving in opposite direction but at the same speed, what will be their momentum? So when they are coming from the opposite side, so their direction is opposite, so they will cancel each other. The momentum of each object will be of the same magnitude but a different direction. So there will be a negative sign for the other object who is coming from the other side. So by using this equation, I want you to choose your level to complete the question. You can start with 3 blue questions first and then move to green and pink. You can pause this video for 5 minutes and then let's see how many questions you are able to complete it. Here are the answers. You can mark your answers quickly. Now, very important part of this lesson is you should be able to calculate the speed or velocity during or after collision, and this is valid due to the conservation of momentum. So the law of conservation of momentum states that the momentum is conserved. Conserved means it remains same in any collision or explosion. So when there is no external force acting on an object, so that's the condition for a momentum being conserved. In simple language, we would say in a closed system where no external force acts, we will say the total momentum before the collision of two objects is equal to the total momentum after the collision. So momentum before collision will be same as the momentum after collision. If one object loses momentum, the other object must gain the same amount of momentum. In that case, the momentum remains same. Here is the worked example for that. A railway engine of mass 800 kilogram traveling at 5 meter per second. So one object is a railway engine, collides with and becomes attached to a truck. So the second object is a truck whose mass is 200 kilogram and the speed is 2 meter per second. Calculate the speed of the truck and engine after the collision. So first of all, you have to calculate the momentum before collision. So two objects mass So we would say momentum before equals momentum after. This is the law of conservation of momentum. So first of all, I'm going to calculate the momentum before collision. So momentum before collision is the mass and speed, mass times speed of engine plus mass times speed of a truck. I will get this answer 4,400 and remember the units, which is kilogram meter per second. So this is the momentum before collision. Now, this is the condition law of conservation of momentum. So therefore, momentum after also equal, the momentum before collision is 4,400. So momentum after collision will be 4,400 as well. So based on this information, that truck and engine stuck together after collision. So I can add their masses. So I'm using this equation. Momentum is equals to mass times velocity. I have to find out their velocity. I know the momentum is this, and I know the mass will be added up because after collision they get added up. So total mass will be 800 plus 200, which is 1000 kilogram. Velocity I need to calculate, and the momentum is this. By putting this value into this equation, that momentum divided by mass is equals to velocity. So by this I have calculated the speed is 4.4 meter per second. Based on this information, now you should be able to calculate the second example, which is here. A 0.5 kilogram trolley is pushed at a velocity of 1.2 meter per second into a stationary trolley of mass 1.5 kilogram. The two trolleys stick to each other after the collision or impact. Calculate the momentum of the 0.5 kilo trolley before the collision and the velocity of the two trolleys straight after the impact. So you can pause this video first and then try. After 5 minutes, I will help you, or I will show you my answer. Well done if you got correct answer. I can explain here once again. So first part was the momentum of the 0.5 kilogram trolley before the collision. So mass times velocity. So trolley's mass was 0.5 and the velocity was 1.2. So the total momentum of one trolley is 0.6 kilogram. Now the momentum before collision. So the momentum of one trolley is 0.6 and momentum of second trolley will be 0 because the second trolley was stationary. It was not moving. It doesn't have any velocity. So it has no momentum. So the total momentum before collision will be 0.6 kilogram meter per second. Now this is the same collision after collision. Now we will use the equation velocity equals momentum divided by total mass. So momentum is 0.6 and total mass is 0.5 plus 1.5, which is 2 kilogram. So 0.6 divided by 2 equals 0.3 meter per second is the answer for the velocity. There is another example when two trolleys traveling in opposite direction. As I told you, when the trolleys are coming in opposite direction, their momentum is opposite to each other. So one will be positive, one will be negative. From the data below, calculate the velocity of the trolley after the collision. So the data for trolley A is in the blue and the data of trolley B is in the green. So you can pause this video and then you can try your answer. Welcome back. So you can see the total momentum before collision will be 4 because both trolleys are coming in opposite direction. So you will take away 24, take away 20. And mass after collision, because they stick together, that will be 5. And then momentum after collision is 4. And by using the equation, your velocity is 0.5 meter per second.